Hey, gentlemen. Hadn't talked to you in a while. Welcome back to Roswell, New Mexico. Today we're going to talk about rate problems. Now, this is just a worksheet with 4 rate problems. I'm going to work 2 and then assign the other 2 to you, gentlemen. So let's get busy so we can keep this video kind of short. Yeah, you can read this first one just as good as me, but it says, Mike can paint a house in 3 days. Jim can paint the same house in 5 days. How long will it take Mike and Jim to paint the house working together? Okay. Now, let's take a look at how we might break this down in a way that'll make it fairly straightforward. So this statement right here, it says Mike can paint a house in 3 days. That's the same thing as saying that Mike can paint 1/3 of a house in a day. Now, you may already see why this is useful, but that's a kind of a way to break it down mathematically. If he can paint an entire house in 3 days, he can paint 1/3 of that house in a single day. Okay, again, y'all, this reads, if he can paint a house in 3 days, he can paint 1/3 of that house in a single day. Now, for Jim, it'd be the same thing. If he can paint a house in 5 days, he could paint 1/5 of that house in a single day. So it says, how long will it take them if they're working together? Well, if we let T be that time, if we let T be the required time, well, we know that rate times time gives you the finished product, right? So what we could do is write it down like this. We could write down for Mike, it's 1/3 of a house in a day. Now I'll leave that out, but it's 1/3 of a house in a day times T. Now you'll see notice how the time units right here would cancel with the day units, okay? The time that we're dealing with is day, not hour. So the day is kind of our unit of time in this particular type of problem. So if you just think about this, T is in time, and the time would cancel out with the days. So you see, now this is going to be, this is Mike's contribution to things. Now, Jim's contribution would be 1/5 times T. All right, now what is this equal to? They're just trying to paint one house, right? One house, so it's going to equal to 1. Now again, y'all, just to avoid the awkwardness of writing down the units, this would literally say 1/3 house per day. But this is T days, right? T days, so that the days will cancel. If you just think of the house over days as a common fraction, and your answer will be in houses, right? It's a single house in this case, right? So again, I think that's the most straightforward way to set this thing up. You guys may have other ways. I know Moises always has some other approach, and that's fine. But this has just been the way I've taught it over the years, and it's worked out okay. But again, I'm inspired when I see different approaches, and I've seen a couple of different approaches on these type of rate problems. Now, so what we have right here, folks, is one equation and one unknown. If we can solve this expression for T, we'll be done. Now, y'all, a common approach in elementary algebra courses is to factor out anything you can factor out. Well, T is common to both of these terms. And so what you can write, and y'all, I'll come over here to make sure I have room. You can write T times 1/3 plus 1/5 equals to 1. Y'all, sorry, I'm getting kind of, let's get this straightened out here, folks. So, y'all, what notice right here, T was common to both of these terms. T was common to both of these terms. And so all I did was just take it out right over here. So that means we have to be able to add 2 fractions. Well, right over here, you can write this as T. Now you can write this as 5/15. Where am I getting 15, folks? That's the common denominator here. Plus 3/15 equals to 1. Okay? And again, y'all, 3 and 5 have a common denominator of 15. You can write 1/3 as 5/15. You can write 1/5 as 3/15, right? Okay. And so continuing, this is 8 over 15. And y'all, it's kind of conventional to write it out front. 8 over 15 times t equals to that one house, right? Okay, well, how do we solve something like this, folks? You can multiply by what they call the reciprocal, or if you don't like that word, multiply by 15 and divide by 8, and you'll get t is equal to 15 over 8, and that's going to be days. Okay, and y'all, that makes a little bit of sense. You would expect, Jim is slower, right? It takes him 5 days, and so he's going to help out Mike a little bit. Mike could have done it by himself in 3 days, but here they did it in just under 2 days, right? Right, folks? That's the same as 1 7/8 days. You know, you're more than welcome to leave it that way. Either way, you can leave it in this so-called improper fraction form, or you can write it what they call mixed fraction form. It makes no difference to me. Okay? Now, let's just check that. And again, for reasonableness, if you'd gotten an answer bigger than 3, you probably figure that Jim and Mike are fighting over the same girl or trying to settle a debt or something, right? You would definitely expect their rates, as long as they're cooperating, to produce an answer that's less than 3. Okay? Because like I say, Mike can do it in 3 days all by himself, right? So you would expect an answer less than 3 days. In this case, that happened. You got an answer even less than 2 days. So look for that. That's kind of critical thinking. If you got an answer out of this world like 4, like some people just say, oh, it'll take them 4 because they're just taking the average. But that's simple-minded thinking, right? They're working together. One of them's faster than the other one, but the slower one is still going to make this guy faster than 3 days, right? So we happen to get it right, but if we'd gotten some other number, you could have questioned it just on common sense, independent of all the math. Okay? All right, folks. Now, what I want you all to do is work this one as your homework problem number 1. Okay? This is homework problem number 1. Okay? Homework problem number 1. And again, by the time you see this, it'll be a Canvas quiz. It'll be due 2 days after you see this assignment on Wednesday. But you can look in the Canvas calendar and you can see everything. It'll be file uploads. I promise I won't forget to make it an upload this time, guys. It'll be a file upload. You'll just take pictures. If you want to, you can take. If you need 2 pictures, just dump 2 pictures into a Word document. 3, 4, however many pictures you take, dump it all into a single Word document, and then just submit that single document on your upload. Now, I'll give you 2 attempts this time. Just if something goes wrong, whatever, you can't find something or whatever, I'll give you 2 attempts. Last time I only gave you 1 attempt to upload it. And most of you can get it uploaded in one attempt, but just, such stuff happens. And so I'll give you a couple of attempts this time in the event something goes wrong on your end in terms of taking the picture or finding the files or whatever. Okay? All right, again, folks, this is homework problem number 1. Now, let's take a look at this example right down here. Okay? It says a boat can travel 16 miles upstream in a river in 2 hours. The same boat can travel 36 miles downstream in 3 hours. What is the speed of the boat in still water? What is the speed of the current? All right. So again, there's an assumption that the river is moving at a certain pace. Now, y'all, upstream means against the current. Okay, just some language. It means against the speed of the current, against the current. That's what the word is. And most people know what that means, but I've seen some people, the words, that's not a familiar term to them. But you ask any kind of hunter, anybody that lives out in the country, they know what this means. Against the current. Now, downstream means it's with the current, right? So the water is pushing you along faster. Right here, the water is pushing against you, slowing you down. Okay? Now, we all know that distance times speed is equal to time. That's let's say you're going 50 miles an hour and you do that for 3 hours. You're going to travel 150 miles, right? So distance is equal to speed times time. We're just going to use that and see what happens here. So, y'all, what I'm going to do right here, our distance upstream is 16 miles, right? 16 miles. Now, distance is equal to speed times time. Well, let's use some convenient letters. I'm going to use B for the speed of the boat and C for the speed of the current. Well, if the current is opposing your motion in the water, it makes sense to subtract the speed of the current from the speed of the boat. And that makes all the sense in the world. And it said it took 2 hours, so put a 2 there, folks. So again, distance, speed, time. Distance is equal to speed times time. Some people call it distance is equal to rate times time. You've seen distance is equal to RT. I call it distance is equal to ST. So this, y'all, this right here is the upstream condition right here, right? Upstream. Okay. Now, as it stands, we'd be in a jam right here, because when you have one equation and two unknowns, you're not going to get anywhere. You need more information. Well, that's where the downstream information is going to help you. Now here, running with that water, man, the guy made it 36 miles. The guy, the girl, whoever feels like getting in that canoe or boat. Now, y'all, this time they're going with the current. The current is adding to their effective speed. And so you'll add the current. And also that was a 3-hour excursion. Okay, and again, this is the downstream event, or the downstream, downstream motion there. Okay. Now, so I don't want to run out. There you go, gentlemen. Are we doing all right? Okay, I hope that's legible and readable. I can see it clearly, and I think you guys are seeing the same image I'm seeing here on this document camera. It's the same one that was in our classroom, by the way. They let me take it home, so that's nice. No more gloves. All right, now, so guys, what we have right here is 2 equations, 2 unknowns, and that means that anytime you have that, theoretically at least, as long as you have as many equations as unknowns, you're going to be able to solve it. It may be hard, may be easy, but that's just the spirit and the theory of equations. If you have as many equations as unknown, you should be able to solve it. Okay. Now, there's more than one approach here. It's tempting to try to distribute the 2 here and the 3 here, but a better approach is to divide this top equation by 2. Now, if you do that, you're going to get, I'm going to come over here. Let's see if we can, I'm trying to figure out what I'm doing here. I'm going to divide this equation by 2 all the way across just to simplify things. Okay. Y'all good with that? I divided this equation by 2, divide the 2 here, it becomes 1, divide the 2 here, it becomes 8, right? Now, right here, the judicious division would be 3, right? If you divide this by 3, you get 12. And again, if you divide this side by 3, the 3's cancel, right? The 3 over 3 is 1. This one's kind of a room service problem. Sometimes it doesn't work out this nicely, but y'all may have seen when you work a system like this, you can actually just add the 2 equations to each other. Now, why would you do that? Well, what's going to happen here is you're going to get a favorable elimination. When you add, the currents will cancel. You'll end up with 20 is equal to 2b. And then, again, remember, B is what? The speed of the boat in still water. And so this means that B is equal to 10. So the speed of that boat is 10 miles per hour. Okay. And also, from this equation right here, if you put B equals 10, that forces C to equal 2, right? So B equals 10, substituted right here, forces, actually, it's even easier to see it right here, folks. If you put 10 right there, you know that C has to be 2, right? You're comfortable there. You don't have to be fancy, folks. You're more than welcome to do it. You don't have to be formal about our mathematics. If we know B is equal to 10 and it's sitting right there, by inspection, C is equal to 2. All right, so your answer for this problem would be the speed of the boat is 10 and the speed of the current is 2. Okay, and y'all, this is called it's called the elimination method. Sometimes they have something called the substitution method, where you can substitute for one in terms of the other and then plug it into the other equation. Here, it's just kind of a made-to-order problem where if you add the 2 equations up, the C's eliminate. That's why they call it, minus C plus C eliminates. It's equal to 0, right? So that, in this case, elimination is certainly easier than substitution. Okay? All right. So good enough on that one, folks. Now, the problem I want you to work, and it's perhaps a little more challenging than the 3 that I've just done, and so I'll understand it if you guys need some hints or want to send me some whatever. I mean, I can try to help you on this one. Now, some of you may know how to solve it directly. I'm not trying to intimidate or act, but it is a little different than these other 3. It's still a rate problem, but it's a slightly more involved problem in my opinion. But I want you guys to do this as your homework problem number 2. All right? All right, gents. that is it. This is your second homework problem. I miss shooting the breeze with you guys, talking football. I guess that's just the way the world's turning these days. Hope that you all see this and view this in good health. Till next time.